Dear students, in the earlier sessions, we have discussed the theory of production or input-output relations. Mainly, we have considered three types of production functions. Production function with one variable input, production function with two variable inputs, and production with all variable inputs. That is, what happens to output when a firm keeps all inputs as constant and varies only one input. That is the case of law of variable proportions or production with one variable input. Now, in the second case, we have seen what happens to output when a firm uses different combinations of inputs, and also how to obtain least cost combination of inputs. And there we have used the technique of isoquants and isocost curves. Now, in this session, we are going to discuss about cost-output relations or theory of cost. And our main focus here is on two aspects. One is short-run cost functions and also long-run cost functions. The most important point to remember here is theory of production provides the background information required for the development of theory of cost. Our production functions are the duals of cost functions. We can derive the cost functions from production functions. Let us start with a simple isoquant and isocost map or production with two variable inputs. In the earlier sessions, we have used this isoquant for 100 units, 200, 300. This is isoquant map. And the slope of isoquant gives the ratio of marginal productivity of two inputs. And we have also seen these are the isocost curves. Isocost for 1500, 12,500 and 3,500. And in the earlier session, we have seen the point of tangency indicates equilibrium. Here, this is equilibrium point for 200, and this is equilibrium point for 300 units of output. And if you connect these successive equilibrium points, this is called expansion path. Each one is the equilibrium quantity. This is the least cost of producing 100 units, least cost of producing 200 units, and the least cost of producing 300 units. Now, if you relate these two in the form of a function or schedule or a table, you will get a cost function. So here now we are relating output and cost. 100 units, what is the least cost of producing 100 units of output? 1500, 200 units, 2500, and 300 units, 3500. This is known as a simple cost function. Now, you can also write the cost function as a C. Total cost, C stands for total cost is equal to F fixed cost and variable cost. So B stands for variable cost per unit into number of units gives you total variable cost. In our table, for example, if fixed cost is say 500 and quantity of output is 100, variable cost for is 10 per unit. 10 into 100, 1000 plus 500, 1500. So the cost of producing 100 units of output is 1500, and similarly for 200 units it is 2500, and for 300 units it is 3500. This is a simple cost function. Now, before explaining the short-run cost functions, let us know about the meaning of certain terminology, like what is the social cost of production, also called as opportunity cost or alternative cost, and what is explicit cost, implicit cost, what is accounting profit, and what is economic profit. And these are the important concepts which we use very frequently, and we begin with simple cost concepts. That is, what is the social cost of production? Depending on the type of political system operating in the country, every society possesses a pool of resources. So the resources at the disposal of a country are limited, we know that. And the resources can be used for different purposes. And those resources that are used for the production of say X are not available for the production of say another commodity, say Y. So resources can be used for the production of X or Y. And if you allot the resources for the production of X, that means they are not available for the production of Y. There is a social cost of producing X. The social cost of producing X is the number of units of Y that are sacrificed in the process of producing X instead of Y. And economists, they call it as alternative cost or opportunity cost also. So a famous wartime example is the guns and butter problem. Those resources that are devoted for the production of guns are not available for the production of butter. So the social cost of producing guns is the amount of butter or quantity of butter or value of butter that is sacrificed in the process of producing the guns. Okay, so this is about the social cost. Next, what is explicit cost? So use of resources entails a social cost that we have seen. There is also a private cost. For example, the entrepreneur, if he wants to produce a commodity, he has to pay to the resource owners or owners of factors of production or input owners or resource owners. So all the amounts paid by the entrepreneur to the owners of factors of production or resources or inputs is known as explicit cost. All the amounts paid. All the amounts paid by the entrepreneur for the purpose of production of a particular commodity. Now, so imagine a producer or an entrepreneur purchases inputs and makes a product, sells in the market, and he makes a comparison of sale proceeds or revenue minus these expenses, total cost, and the result is known as profit. The excess of revenue over expenditure is known as profit. This is simple accounting profit. But economic profit is different from that of accounting profit. This is a pure accounting way of determining profit. Here, there are some more items you have to consider. You have to include few more items in the cost. What about the money invested by the entrepreneur? And what about the time allotted by this entrepreneur for this line of activity? Had he not undertaken this line of business, he could have invested his money in a bank, for example, or in interest yielding bonds or securities, so that he can get some interest income. So he is foregoing interest by way of investing his own money in the business. Similarly, the time allotted by the entrepreneur. He could otherwise join as an employee in some other organization. He could get some salary income. He is foregoing that also. So you have to put a value for these also, time. The imputed value, we call it as opportunity cost. That is also called implicit cost. So total cost consists of explicit cost plus implicit cost. The value of next best alternative, that is called implicit cost, and we also call it as opportunity cost. Opportunity cost of using his own investment money and also time, that is called implicit cost, and you have to take these two into consideration, that constitutes the total cost. And now the profit is known as economic profit. If revenue is more than both explicit and implicit cost, that is called pure economic profit. So that is, he is earning over and above the normal rate of return, which could be earned in the alternative ways of investment. So this is surplus generated beyond the normal rate of return. So pure economic profit is different from that of accounting profit. So these are the important cost concepts. Now let us discuss about short-run cost functions. What is short run and what is long run? In economics, we frequently use the words short run and long run. Short run refers to that period of time during which some inputs are fixed and some inputs are variable, and output adjustments, either increase or decrease, are possible only through variable input usage. So that time period is known as short run. It is not a fixed calendar period. So what is the minimum period of time required to change certain inputs? That is called short run. Suppose there is a demand for the product. All of a sudden the firm cannot increase or decrease fixed inputs like buildings, plant, machinery, or managerial personnel, that takes time, minimum time. For example, construction of a building requires a 6 months time. During that 6 months, you cannot change this, and that 6 months is known as short run. Okay. What is the alternative in the short run? Output can be increased or decreased, no doubt, to some extent. Up to the maximum capacity of the fixed inputs, you can use more variable inputs. By way of using more variable inputs, you can increase or decrease the level of output to some extent in the short run. And long run refers to that period of time during which all inputs are variable. There are no fixed inputs in the long run. That implies that output can be increased or decreased without any limitation. If desired, output can also be totally closed down. The factory can be shut down. So these are some of the important aspects, both short run and long run. So corollary to this, fixed inputs, they give rise to fixed cost, and variable input give rise to variable cost. And the total cost is equal to sum of fixed inputs, fixed cost plus variable cost. So in the long run, there are two types of cost. One is fixed cost and second one is variable cost. Now we need to know the important meanings of these things. What is fixed cost? Fixed cost remains constant irrespective of the level of output. If output is 0 to the maximum capacity of the plant, it remains constant. Fixed cost remains constant irrespective of the level of output. Even if output is 0, there will be fixed cost. And it remains up to what level? Up to the maximum capacity of the plant. Even if the firm temporarily shuts down its operations, then also it has to incur the fixed cost component. It cannot avoid unavoidable cost. Fixed cost is unavoidable. It cannot avoid the cost. It has to meet the fixed expenditure. Whereas the variable cost, it varies with the level of output. If output increases, variable cost increases, and if output decreases, variable cost decreases. If the firm wants to increase the level of output, it has to use more variable inputs, and accordingly variable cost increases. If output is 0, variable cost is 0. If output increases, variable cost increases. These are the important features or characteristics of fixed cost and variable cost. As I told you earlier, the same points we try to explain with the help of numbers and also with the help of a graphical presentation. So these are only aids to explain a concept or proposition. So let us take the case of a firm whose output schedule is given here. Output increases from say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It may be thousands of units. 1 means 1,000 units, like that, imagine. And where also the second column gives you total fixed cost, third one total variable cost, and fourth one total cost. Let us discuss initially up to total functions. So now see first column and second column. What you observe here. As quantity of output goes on increasing, fixed cost remains constant. That's what we have said. That is, fixed cost remains constant irrespective of the level of output. Even if output is 0, then also fixed cost would be 100 here. Up to 15 or 15,000, it remains same. So if you want to present the same in the form of a graphical presentation, the curve will be like this. Total fixed cost. So this is x-axis. On x-axis you represent output. On y-axis you represent cost. And this is say 100. This is a horizontal straight line indicates the total fixed cost. Indeed, total fixed cost is constant. 0, 100, 100, 200, 300, 400, 1500. It remains same. So total fixed cost is a horizontal straight line, indicating that it remains a constant irrespective of the level of output. Very simple. Now let us see what is the total variable cost. So if the firm wants to increase more units of output, it has to use more variable inputs, and accordingly it has to incur more variable cost. So variable cost increases from 10, 16, 21, 26, 30, 36, 45, 56, 72, 90, 109, 130.4, 160, 198.2, 249. So now let us draw the variable cost. Total variable cost, it starts from origin. Total fixed cost starts from a vertical intercept, because even if output is 0, total fixed cost is 100. So it starts from vertical, it has a vertical intercept. Whereas the variable cost, if output is 0, variable cost is 0. So it starts from origin, and the curve will be like this. Total variable cost. Okay. So output is 0, total variable cost is 0, it increases like this. Initially it increases at a decreasing rate, and then it increases at an increasing rate. Total variable cost initially increase at a decreasing rate, and then at an increasing rate. So anyway it is increasing like this. Now what is total cost? How to calculate column 4? Column 4 is nothing but the sum of column 2 and 3. Total fixed cost plus total variable cost gives you total cost. If you simply add these two, 100 plus 10, 110, 100 plus 16, 116, 100 plus 21, 121, 100 plus 26, 126, so on and so forth. Now, if you draw the total cost curve, again it starts from a vertical intercept, because if output is 0, what is total cost? Total cost is equal to the fixed cost component. So it starts from vertical intercept, and it will be like this. Total cost. And the important point to remember is, in the numerical table and in the graphical presentation, you can see that the difference between total cost and total variable cost is always equal. Always they are separated by 100. For example, here are fixed cost component 126 to 2600, or say 172 72 100. So the difference between total cost and total variable cost is constant or same. And for example, here it is 100, or you can see here the same distance or somewhere here. Same. So you have to draw the lines in such a way that the total cost and total variable cost are parallel to each other. Only care you have to take is both TVC and TC must be parallel to each other. That means, that indicates that they are separated by a constant vertical distance. This is about total functions. Now, more important for our purpose and also for understanding price output decisions under different types of markets, they are average functions. Let us start with average fixed cost, average variable cost, average cost, and marginal cost. These are more important compared to the total functions. So column number 5 is given by average fixed cost. What is the average fixed cost? How you get average? Average is always total divided by number gives you average. Very simple. So total fixed cost divided by number of units of output gives you average fixed cost. AFC is equal to total fixed cost by O, number of units of output. That is 100 by 1, 100 by 2, 100 by 3, 100 by 4, 100 by 5. That is, numerator is always same and denominator is increasing. You are dividing a constant figure with increasing numbers. Numerator is always 100 and denominator is gradually increasing. So the result will be continuously declining. So average fixed cost continuously declines, 100, 50, 33 like this, goes on decreasing. Now if you draw the diagram, this will be like this. Average fixed cost continuously declines and becomes like this, asymptotically closer to y and x axis. This is here output and cost. On x axis you write output and on y cost. And this is AFC, average fixed cost curve. AFC is a rectangular hyperbola. The simple reason is the numerator is always same and the denominator is increasing. So that's a very simple function, total fixed, average fixed cost. Let us see average variable cost. How to calculate average variable cost? Formula is total variable cost divided by number of units of output, TVC by O. Okay. Now let us see what is the AVC. Total variable cost 10 by 1, 16 by 2, 8, 21 by 3, 27, 26 by 4, 6.5, 6, so on and so forth. So it declines 10, 8, 7, 6.5, 6 up to this. It declines, reaches minimum and then increases 6.5, 7, 8, 9, 9, 10, 12.3, 14, 16.6. Okay. So what is the feature you are observing? Average cost initially declines, reaches minimum and then rises. So while writing the diagram, you have to see that average variable cost curve initially declines, reaches minimum and then rises. AVC. This is minimum point of AVC. Okay. So you observe AVC initially declines, reaches minimum at this point at point 4 and rises thereafter. Why AVC? What is the shape of AVC? It is U-shaped. Initially declines, reaches minimum and then rises. Why AVC is of U-shape? The reasons for the curvature can be drawn from or derived from the theory of production. I mentioned in the earlier session that theory of production and theory of cost, they are the jewels of each other. Cost functions and production functions are the jewels of each other. Now let us see here. Okay, we will come to that point later. Let us complete the other items also. So what is the average cost? Average cost, there are two ways of calculating average cost. AFC plus AC is equal to average cost. That is column number 7 can be derived by way of summing column 5 and 6. Sum of average fixed cost and average variable cost gives you average cost. That is one way. And second one is average cost is equal to AC is equal to AFC plus AVC, or AC is equal to total cost by output. There are two ways of calculating average cost, by way of summing average fixed cost and average variable cost, or by dividing total cost by number of units of output. Now see how average cost appears. 110, 58, 40, 31.5, 26, 22, 20, 19, 19, 19, again here 19. And again rises 19.2, 20, 21, 23. That means AC initially declines, reaches minimum and then increases. It's a U-shaped curve. Initially declines, reaches minimum and then increases. This is average cost curve. This is the minimum point of AC. Say point 3. 1, 2, 3, 4. Okay. You call it 5. So now let us see. Average cost initially declines, reaches minimum at point 3 and then rises. And it is asymptotically closer to AVC as indicated by point 5. AFC is asymptotically closer to y-axis at 1 or closer to x-axis at 2. And similarly, AVC is closer to AC at point as indicated by point 5, asymptotically closer. Now the last and most important function is MC. Before that, let us see, AC is a U-shaped curve. We have seen here that it is U-shaped one. Initially declines, reaches the minimum and then rises. The reasons for why AC is U-shaped, or the reasons for the curvature, can be explained with the help of this point. That is, AC is nothing but the sum of AVC and AFC. Let us see in the beginning, up to this level of output, what happens. Up to this level of output, AFC, in the initial stages, AFC is declining and AVC is declining. Both AFC and AVC both are declining. So AC declines, okay. Later, though this ABC takes an upturn, the marked increase in AFC more than compensates the slight increase in AVC. So AC continues to diminish, okay. So up to this point is reached. Later what happens is, the marked increase in AVC more than compensates the slight decline in AFC. Here the rate of decline in AFC gradually diminishes. So the marked increase in AVC more than compensates the slight decline in AFC, and as a result AC starts increasing, takes an upturn and starts increasing. So that is the reason for the curvature of AC, U-shape, why AC is a U-shaped curve. The last and most important point is MC. Usually how you calculate what is marginal cost, very, very important concept in economics, marginal. Always marginal is addition to total, attributable to the addition of one more unit. So we have marginal cost, marginal revenue, marginal product, marginal utility, whatever is the concept. Always how total is changing, the rate of change in total indicates marginal. Okay. So in our case, addition to total cost attributable to the addition of one more unit to output is known as marginal cost. If one more unit is added extra, what is the extra added to the total cost? That is known as marginal cost. So there are two ways of calculating marginal cost. That is, one is marginal cost is equal to delta TC, change in total cost by change in output. In our example, change in output is always 1 unit. Suppose 1 to 2, 1. Change is 1, 2 to 3. Delta output is 1, 3 to 4, 4 to 5. Always 1. So denominator is 0. Delta 0 is equal to always 1. So you can ignore this. So delta TC indicates marginal. Change in total cost gives you marginal cost in our example, because denominator is always 1, restricted to 1 unit change. There is another way of calculating marginal, that is, we know that total changes only because of total variable cost. Total cost changes because of change in variable cost, because fixed cost remains constant. So you can also calculate by taking the change in total variable cost. Marginal cost is equal to delta TVC by delta O. By subtracting successive entries in the total cost column, you can calculate marginal cost. And similarly, by subtracting successive entries in the total variable cost also, you can calculate marginal cost. There are two ways of calculating marginal cost. So the marginal cost figures are given here. You can see in the last column is marginal cost, 6554. So it declined. Minimum point is 4 and then starts rising, 6, 9.5, etc. 10, 16, 18, etc. Initially declines, reaches minimum and then rises. And you see that MC reaches minimum prior to that of AVC and also AC. First MC reaches minimum and then AVC reaches minimum and lastly AC reaches minimum. MC reaches minimum prior to that of AVC and AC. So let us draw the marginal cost like this. Initially declines, reaches minimum and then rises, and while increasing it intersects AVC at its minimum point and also AC at its minimum point. This is MC. This is the minimum point of MC. So marginal cost initially declines, reaches minimum and then rises, and while increasing it intersects AVC at its minimum point 0.4 and also AC at its minimum point 0.3. So in the diagram we have drawn the average functions like average fixed cost, average variable cost, average cost and then marginal cost. Let us recollect the important features of these average functions. First, let us start with average fixed cost. Average fixed cost continuously declines and it is asymptotically closer to x-axis and y-axis as indicated by point 1 and point 2. It is a rectangular hyperbola. Now what is AVC? AVC initially declines, reaches minimum and then rises, and while increasing it is asymptotically closer to AC as indicated by point 5. So AVC reaches minimum at point 4 and increases. It is a U-shaped curve. And then AC. AC is also a U-shaped curve. Initially declines, reaches minimum at point 3 and then rises. And the reasons for the curvature can be explained with the help of the simple formula AC is equal to AFC plus AVC. We have seen that initially both AFC and AVC are declining, so AC declines. Later AC continues to decline because even though there is a small rise in AVC, the marked decline in AFC more than compensates the slight increase in AVC. As a result, AC continues to decline. And in the end, the steep increase in AVC more than compensates the small decline in AFC. As a result, AC increases, takes an upturn and then increases. And finally, marginal cost. Initially declines, reaches minimum and then rises, and while increasing it intersects at point 4, AVC at its minimum point and also AC at